All right, so I am going to go ahead and record our session so that anybody that wasn't able to join us can watch later. On anything where I ask you guys questions, feel free to type your answer in the chat, or you can unmute your mic and share verbally, whatever you're most comfortable with. All right, let's start going through this. Number 1 and number 2, it says to simplify. I notice that we have a negative underneath the radical here with this 27. That's the first thing I need to deal with because we can't take the square root of a negative number. So how do I deal with that negative under the radical? How can it come out and get out of my way? Awesome, yes. So we have this -1 that's being multiplied to the 27. When I do that -1 times 27, it's still under my radical. I still need to get it out from there, but we're making good headway. How can I bring that out? How can I bring that -1 out? Because I can't take the square root of a -1. I can't take the square root of a negative anything. I wonder though, make it an I. Absolutely. Morning, Savion. So I'm going to have the square root of 27. And then I have an I at the back so that I get it out of my way. Now that I just have the square root. I'm sorry, one more time.
You could do 9 times 3.
9 times 3 for my 27. Absolutely. I can't really do that while I still have that negative under there because we can't do the square root of negative numbers. But we can do that now that we have that negative out as the I. Can I break that down any more?
You can break 9 down into 3 and 3.
Absolutely correct. We can break the 9 down to be 3 and 3. And then I had that other 3 there. So 3 times 3 times 3 makes 27.
You have a pair of 3.
Yes, absolutely. We got a pair of 3s. So what do I do when I have a pair? Where does it go?
Put on the outside.
Put it on the outside. So I'm going to bring a 3 out to the front. The 3 that doesn't have a pair stays under. Is this my final answer?
Don't you put the I at the end?
Yes. We need that I at the end. Now, it's my fully simplified final answer. Nice work. Okay. Number 2. Before I can actually do anything in number 2, I need to know what it is that I'm supposed to be doing. What operation? What'd you say?
Double distribute.
Double distribute. Yes, we're going to use multiplication here. So we will double distribute. Absolutely correct. So I'm going to take this 2, whoop, kind of overshot the 5 there. I'm going to distribute it to both of these pieces. So I'm going to have 10 minus 14i. And then I need to distribute the 3i as well. So I'm going to have plus 15i and minus 21i squared because I have I times I. Yes. Okay, so now there's 2 things that I can do here. If you know either one of them, please type it into the chat or unmute your mic.
Find like terms.
Like terms.
Then you're going to get a positive 1i.
Yes. This I squared, we're going to replace with a -1. Remember, I to the 4th power is positive 1. I squared is -1.
That turns
The
into
reason for that,
21i.
yes. So I is equal to the square root of -1. I just want to go over real quick why we're replacing it with a -1 there. If I square both sides here, I get I squared equals squaring a square root makes that cancel out. So I squared is always the same as -1. All right, so I have 10. What do I get when I combine my like terms together?
Positive 1i.
Positive 1i, so plus I, or you could do plus 1i, that would be totally fine.
Plus
And then I
21.
have, you said
Positive 21.
positive 21, yes, because I have negative 21 that's being multiplied to a negative 1 there. So when I do that, I get a positive 21.
Then you could do 10 times 21, which would be 31.
Yes, we're going to combine these two like terms. When we combine like terms together, we're always only adding or subtracting there. And so the 10 plus 21, I get 31, absolutely correct, plus I. Beautiful. All right, that puts us now to number 3. Number 3, we're supposed to graph. I'm supposed to graph this thing right here, but I'd really like to know what shape it is that we're supposed to graph. I see a squared on the outside of these parentheses. What kind of a shape do we make when we have a squared? Starts with a P.
Parabola?
Parabola, yes. This is a parabola. And the parent for a parabola is y equals x squared. So that's what I'm going to do first in my table. I'm going to put the parent function there. So I have x over here, I have y over here. We get to pick our x's. X's are the input. We always get to choose those. So I'm going to choose -2, -1, 0, 1, and 2. Those are my 5 favorites. According to the parent function, what are we going to be doing to each of those x's to get our output?
Squaring.
Squaring, yes. And what does it mean to square something?
Times it by itself.
Times it by itself. So if I do -2 times by itself, what do I get?
You said -2 times it by itself.
Yep, -2 times it by itself.
It's 4.
4. What about -1 times it by itself?
1.
1. What about with 0?
0.
0.
Then it
And then-
repeat.
It's going to be 1 and 4 because it repeats itself. Absolutely. All right, so let me go over here and graph those. So here's my parent. A little bit wiggly, but we get the idea. Now I'm looking at this transformation and I want to know what are my values for A, H, and K.
A is 2.
A is 2,
H is +1.
H is +1,
K is -4.
K is -4. What will this H value of +1 do to my graph?
Go right 1.
Gonna make it go right 1, yes. Which axis goes left and right?
X.
X-axis goes left and right. So to make it go right 1, I have to add 1 to each of these x's. That will make it move to the right. So what will my new x's be?
-1, 0, 1, 2, and 3.
Yes, -1, 0, 1, 2, and 3. What will the A value of 2 do to my graph?
It'll
Compress or reflect.
stretch.
It's going to stretch it. It'll either compress, stretch, or reflect it. This is a +2. And if I take 2 and I multiply it by something, it's going to make it bigger. So this is going to vertically stretch it by 2. Since it is a vertical stretch, that affects my y's because the y-axis is the vertical, the up and down axis. So I'm going to multiply all of these by our A value first. That's going to double everything. It'll make it stretch. What about this K value down here? What will that do to my graph?
Go up or down.
Go up or down? Is this one going to go up or down?
Down.
Down negative.
Yes. We're going to go down 4. So after I stretch it, the way I make it go down 4 is by doing what?
You put -4 on the y side.
Yes. I make it go down 4 by subtracting 4 from all of these. So first we stretch, then we shift. So what will my new y's be? So I do 4 times 2.
4.
The
Yep.
first one's 4.
First one's 4,
First one-
Negative 2.
negative 2,
Negative 4.
negative 4,
Negative 2.
negative
Gonna
2,
repeat.
and it's going to
And-
repeat. Yep. So then we have a positive 4 there. So those are the points that we're going to go and graph for our transformation. -1, 4, 0, -2, 1, -4, 2, -2, and 3, +4. Remember when you sketch through, when you trace through these points, this is a parabola. It should have as much of a rounded bottom on it as you can possibly give it. I know the more we stretch it, the harder it is to give it a rounded bottom there, but do your best. So here's our transformation. We just need to do domain and range, and then we'll start our lesson for today. The domain for all parabolas. This is everything I am allowed to use for x.
Infinity.
Yes, -infinity to +infinity. There is no restrictions at all on the things that I'm allowed to square. For the range, though, we do have some restrictions. I'm looking at the red transformation. Range means I'm talking about the x's or the y's.
Y's.
Y's. Do we have a maximum or a minimum on this? A lowest or a highest?
Minimum.
Minimum. This is a minimum, a lowest point.
Is 4. -4.
It is -4. I always put the smallest number first when I'm talking in interval notation. So -4. Does it have a highest point?
It's infinity.
Infinity keeps going on forever and ever. Fantastic. All right. If you guys have your books with you, go ahead and flip them to page 265. If you do not have your books with you, grab your phones and take a picture of that graph, and then on some scratch paper, write down the things that are on the right-hand side of the screen. If you have your books, go to page 265. If you do not have your books, snap a picture of the graph so you have it to look at, and then write down the things that are on the right-hand side of the screen onto a piece of paper or into a notebook. We are going to be talking about our end behavior. So we're going to be looking at the far left side of the graph. Let me write that a little bit better. And the far right side. We're also going to work on identifying our zeros. Who can give me a synonym for zeros?
Roots.
Roots. Anything else?
X-intercept.
Yes, x-intercepts. We've got one more synonym, although this is the one that I'm mainly looking at. Absolutely correct. Solutions. So x-intercepts, since I'm talking about a graph here, that's what I'm going to be keyed in on here. Okay. We're going to talk about degree and leading coefficient, but I want to save that until the end. So hold off on these two for just a couple of minutes. We're going to talk about the end behavior first. We'll talk about our zeros, and then we'll talk about degree and leading coefficient. Okay, so my end behavior, I'm talking about the left and the right ends. Come over here and look at the left end of the graph. I'm looking right here. If I were to draw an arrow on the end of that graph, would that arrow be pointing up or down?
Up.
Up. So over on the left side of my graph, we're pointing up. When I come over here and I look at these math sentences that they have started for me, I'm looking here and here. These are mathematical sentences. Here it says X, so I'm looking at the X axis. That little arrow we read as the word approaches. And then it says negative infinity. If I look at the x-axis where the negative numbers live, what side of the graph am I looking at? The left side or the right side?
The left.
Left side. So this means I'm talking about the left. And what did you guys tell me the left end was doing? Going up or going down?
Up.
Up. The way I explain what the graph is doing, here's what I'm going to write on this line. I use function notation so that everybody knows I'm talking about the graph now. So I'm going to say f of x, that means my graph. And then I use an arrow here too. So as x approaches negative infinity, as I look at the x-axis on the negative side, the left side, my graph, f of x, approaches, and you said it's going up. What kind of numbers live up? Positives or negatives?
Positive.
Positives. So I'm going to put a positive infinity. You can put a little plus sign there like I did. You don't have to have the plus sign for positive infinity, but sometimes it helps to put it there. So far, so good? You guys have some reaction keys that you have access to. Give me a thumbs up if you're doing okay. Give me a crying face if you're not doing okay. Awesome. Thank you, Gina. Thumbs up if you're doing okay. Thank you, Aaliyah. Thank you, Savion. I want to make sure that I haven't lost people. I want to know I've got everybody with me. Thank you, Lauren. Awesome. Thank you, Soraya. Thank you, Axel. Wonderful. Let's see, Kian and Mohammed and Francesca, let me know that I got you guys with me. It's okay if you're not totally firm on these concepts. This is the first time we've ever talked about something like this. I just want to know I still have you with me. All right, let's look at this next math sentence. Up above, it said x with an arrow and then negative infinity. We said that meant we were talking about the left side of the graph. What side of the graph do you think we're talking about when it has the x, but then it has a positive infinity?
The right side.
The right side. This is the right side of the graph. X-axis, positive numbers, that's the right end. So let's go look at the right end of this graph and see what it's doing. So I'm looking right here. If I were to draw an arrow on the right end of that graph, which way would it point?
Down.
Down. So I want to explain that. I want to finish this math sentence. I want to use function notation so that everybody knows I'm talking about the graph. What should I use for my function notation here?
F of x.
F of x, yes. Whatever I called it in the first math sentence, I want everybody to know I'm talking about the same graph. And then I need an arrow. We read this as f of x, or my graph approaches When you look down, what kind of numbers do you see when you look down?
Negative.
Negative. When does it stop going down?
It doesn't.
So how should I explain that?
Negative infinity.
That's absolutely correct. Negative infinity tells me that I'm going down. Beautiful. Fantastic. Okay, let's do our zeros next. We're looking for our x-intercepts. We've got quite a few on this graph. So here's what I do to make sure I don't accidentally miss any. I'll take a pen or my finger, and I'm going to trace along the x-axis. And anytime my graph touches or crosses the x-axis, I'm going to stop and I'm going to write down that ordered pair. So I'm going to start on the left-hand side, trace across here. Ooh, right here, we are touching the x-axis. So I have an x-intercept right here. It looks like it's in between the -6 and the -4. So what do you think that ordered pair would probably be?
-5 and 0.
-5, 0, yes. So that's the first one that I'm going to write down on this line. -5, 0. All right, now I'm going to keep tracing along the x-axis here. I'm going to take my pen over, and right here, we have another spot where it's touching or crossing. So another x-intercept. This one's in between -2 and the y-axis. What do you think that ordered pair would be?
-1 and 0.
-1, 0. So I'm going to write that one down on the line too. And then we continue our field trip across the x-axis. And right here, there's another x-intercept.
4 and 0.
4, 0. I'm going to put that on my line here. Continue my field trip across the x-axis. I've got another one right here in between the 6 and the 8. So that ordered pair is probably what?
7 and 0.
7 and 0. Do we have any other x-intercepts here?
No.
Nope. I follow this then to the end of my graph. All right, there's two pieces that I said we were going to save for the end, the degree and the leading coefficient. So when I'm looking at the degree, I want to know whether the ends are going the same way or different ways. For even, that means my ends are pointing in the same direction. And it is odd if my ends point in opposite directions.
Opposite.
Opposite, yes. So this one would be even or odd?
Odd.
Yes. Left end's going up, right end's going down. So this would be an odd function. For the leading coefficient, I'm still looking at the ends, but I only care about one of them. And I only ever care about one of them for the leading coefficient. We look at the right end only. We say it is positive if the right end is going up. And we say it is negative if the right end is going down. So does this one have a positive or a negative leading coefficient?
Negative.
Negative. Right. We're going to look at another graph. If you have your book, it's still on page 265. It's the one just to the right of this. If you don't have your book, when I change the screen, I want you to take a screenshot of it grab your phone, snap a picture of it so that you can look at the graph. We're going to answer these exact same questions: degree, leading coefficient, end behavior, and zeros. We're going to do the degree and the leading coefficient first. All right, I'm going to put this new graph up. If you don't have your book, snap a picture of this graph, and then we're going to answer these questions. We're going to start with the degree.
It's even.
It is even. How do you know?
Both ends are going up.
Yes. The ends are going the same direction. And that is true on this graph. We would say it's odd if the ends are going in opposite directions. All right, now let's look at this leading coefficient thing. I only look at which end for the leading coefficient. We only look at which end?
Right.
The right. Always and forever. So I'm going to come and look at the right end right here. It's going which way?
Up, so it's a positive leading.
Yes.
coefficient.
It is going up, so it's positive. Beautiful. Now let's talk about our end behavior. So now I'm going to look at both ends, but I need to read the beginning of my sentence so that I know which end we're talking about. They started the sentence for me. It says, as x approaches negative infinity. So I'm looking at the x-axis at the negative side. Is that the left or the right?
The left.
Left. So I'm going to go look at the left end. What is the left end doing?
Going up. So it's
Going
positive.
up. So on the line, I have to explain, to finish this sentence, I have to explain that I'm talking about my graph. How do I explain that I'm talking about the graph?
You go f of x and then you put the arrow and then you put positive infinity.
Yes, f of x means my graph. You can use any kind of function notation there. If you wanted to use g of x or h of x, that would be fine. And then we're going to use a positive infinity to mean up. What about the next sentence, the one right below it?
It's
How
gonna
do
be-
I know which side it's talking about?
Because it's the right side.
And how did you know by looking at it?
Because the positive infinity.
Positive infinity. This has to be the right side because that's where right numbers live on the x-axis. That's where the positive numbers live on the x-axis. So what should the rest of my math sentence look like?
F of x and then you arrow and then another positive infinity.
That's absolutely correct. The f of x means my graph. The positive infinity means up. Beautiful work. We've got one last thing to do. We've got zeros. What am I looking at on the graph for those zeros?
The x.
X-intercepts. You do not have to do these in any particular order, but I find it easiest to not accidentally miss any, to trace across it. How many x-intercepts do you guys see?
4.
4. There's one there, one there, one there, and one there. We want to give these ordered pairs. So what are all 4 ordered pairs here?
It's -3 and 0, -1, 0, 0, 0, and 2, 0.
That's absolutely correct. Let me get the rest of these labeled here and then I'll write those down. We have -3, 0, -1, 0, 0, 0, and 2, 0. So that's what I need on my line. -3, 0, -1, 0, 0, 0, and 2, 0. All right. I'm going to put up another graph. I want you guys to answer the exact same questions that we've been doing with this. I want you guys to try this one on your own, and then I'll put up my answers after you guys have had about 4 minutes to work on this on your own. So new graph coming up. If you don't have your book with you, take a picture of the graph so that you have it to look back at later. We will talk about domain and range with this after we answer the other questions. So you can hold off and wait on domain and range, but I want you to answer the other pieces of this: even or odd, leading coefficient, end behavior, and zeros. I give you guys about 3.5, 4 minutes to do that. Mostly Savion, yes. You might need to put arrows on the ends of it because they don't always draw arrows on the ends. For the degree, you're looking at both arrows, whether or not they go the same or opposite ways. Don't care whether they both point up or both point down. I'm just looking for same or different. For the leading coefficient, yes. I'm looking just at the arrow and only on the right side. That's absolutely correct. About 1 more minute, and then we're going to go through this one. You guys are doing fantastic with this, by the way. Is this even or odd? Is this graph even or odd? You can can type it into the chat or you can unmute your mic. Odd. Thank you, Aaliyah. It is odd because when I look at the ends, I see that one end is pointing down and the other end is going the opposite direction. So one up, one down. Does it have a positive or a negative leading coefficient? Positive or negative leading coefficient? Only looking at the right end for this. Type it into the chat. You can do a plus or a minus sign. Positive, yes. Positive because the right end is pointing up. All right, we'll come back to domain and range in a minute. Let's go to our end behavior. As x approaches negative infinity, means I'm looking at which side of this graph. As x approaches negative infinity, I'm looking at which side? The left side. Which way is the left side going?
Down.
Down. So how do I explain that?
F of x, arrow, negative infinity.
Absolutely correct. What about as x approaches positive infinity? Is that left or right?
Right.
Right. What is the right side of our graph doing?
Going up.
Right side is going up. So how do I explain that?
F of x infinity, arrow infinity.
Yes, f of x approaches, you can write it as just infinity, or you can put the little plus sign there. Totally up to you. How many x-intercepts do we have? How many x-intercepts do we have?
5.
5. 1, 2, 3, 4, 5. So we've got one at -5, 0, one at -3, 0, one at 0, 0, one at +3, 0, and then one at 6, 0. Beautiful. Domain and range. Domain. If that graph goes to both ends, it is negative infinity to positive infinity. For the range, does one of my ends point down?
Yes.
Yes. So there is no limit on the negative y's that we can get because one end points down. Does one end point up?
Yeah.
And there is no limit to the positive y values we can get. If my ends pointed the same direction, then I would have a minimum somewhere on my graph. If both ends pointed down, then I would have a maximum somewhere on my graph. If my ends point in opposite directions, then my range will be negative infinity to positive infinity.
Is the domain always going to be the same?
Pretty much. If it's ever not negative infinity to positive infinity, we will talk about it quite a bit. All right. Before you guys head out, homework 2 isn't going to be due until Thursday morning. We're going to keep talking about this stuff tomorrow. Long-term behavior with graphs and equations is homework 2. Any of the ones with graphs you can do. Any of the equation stuff we will talk about tomorrow in class so that you can do those. I hope you guys have a fantastic rest of your day. You can get a hold of me through Canvas, and I will see you guys later. Have a good one, everybody.